Hiya, we're going to have a look at end behaviour of a polynomial. So first I'm just going to set up a left and a right hand side just to help explain it a little better and to make things a little bit easier for you. So first you need to make sure your polynomial is in standard form, and that means your exponents have to be in decreasing order from highest to lowest. So the exponents go from left to right. Ours does, so we don't need to change anything. Then we look at the leading coefficient, which is the number in front of the variable of the highest degree. If it is negative, it means the right-hand side behaviour goes downwards. Think of linear equations. If you have a negative linear function, it's going to slope downwards, left to right. And in a similar fashion, if that number was positive, the right-hand behaviour would go up, or a positive linear slope. Then you need to have a look at the degree to determine the left behaviour. And we need to know whether it is odd or even. If it is even, like it is here, it's a 2, it means it matches the right hand side behaviour. So our right hand side behaviour here went down, which means the left hand side behaviour is going to go down. Here, the right hand behaviour went up, so this left-hand behaviour would go up. If it was odd, however, it would be the reverse. So here we have right hand going down, we would have left going up. Here we have right going up, we would have left going down. So to just rehash all that, or put that in a summary, for the right-hand side behaviour, you're only going to look at the coefficient. If it is negative, it's going to go down to the right. If it's positive, it's going to go up to the right. And for your left-hand side behaviour, we look at the degree of the highest variable or highest exponent. If it is an even number, it matches the right-hand side. If it is an odd number, it goes against the right-hand side behaviour. I hope that helps. Now describing it, we can say up or down. We can say rises or falls to the left or to the right. Or you may see it look like as y approaches negative infinity, x approaches negative infinity. And how you determine that, if you can't visualise it, just draw a quick little set of axes. You don't even have to label them. And draw it. If you know it goes down to the right, you can see that x is approaching infinity and y is approaching negative infinity. And then that just goes into a statement. So y approaches negative infinity as x approaches infinity. So what does that mean for our polynomial right here? So let's have a look. We have a negative 2, so our right hand side is going to go down because it's negative. Our left hand side is even, so it's also going to go down because when they're even, it is the same as what's happening on the right. So I could write this as down, down. I could write it as falls to the left, falls to the right, or using the tends to infinity notation, as it goes down, y is approaching negative infinity as x approaches negative infinity, and y is approaching negative infinity as x approaches positive infinity. I hope that helps explain end behaviour a little bit for you.